good morning. My name is Martin Weichshofer, and I'm a software engineer at GTEC. And this is my colleague Bernard Wong. And together we are working on the Unicorn. And this is the device most of the people are using during this hackathon. And that's why I want to show you about the available hard and software tools and give you an overview about all the tools and frameworks that are available right now. So this is a default Unicorn setup as it comes if you purchase it from the web shop. So it's a plug and play system that you can use basically out of the box. So as you can see, the system consists of an amplifier. And that's this black device on the bottom. Then you have electrodes, an EEG cap. Sometimes you want to use gel, so that's why there's also a gel on this image. And you need a computer. And basically that's everything you need to start out of the box. And then within a couple of minutes, you should be able to use the BCI system. And that's what we are also going to show live in a couple of minutes. So this is the Unicorn amplifier. It has 8 EEG electrodes. You can see the electrode tips on this image, as well as the amplifier, and it features a pretty nice LED bow that you can also control, so you can flash the lights there. And that's the second version available of the Unicorn. It's the Unicorn Naked. So if you're a maker or artist, or you want to make a lot of DIY projects, you can also use the Unicorn Naked and create your own case, your own amplifier boxing, housing, make a good-looking EEG headset, a 3D printed EEG headset. So there are a lot of possibilities to integrate the Unicorn Naked into your project if you don't want to use the standard EEG cap. So the big advantage of having an EEG cap is that it's clinically tested, and you have a lot. We know that you have a good EEG using EEG caps, but with the Unicorn Naked, you can create your own headset. And here is a nice example that I found online from a customer who did exactly that. He purchased the Unicorn Naked and created his own amplifier housing with another connector because he wanted to use sponge electrodes. This is from Robert Ostenfeld. This is very famous in the field of BCI. And on the right-hand side, you can see an example that we also put on GitHub, where we created an amplifier housing that you could integrate into a headband. And as you can see, there are plenty of institutes and companies who are already relying on the Unicorn. So right now, the Unicorn is well tested and around for a couple of years. So now to a couple of technical hard facts about the Unicorn. So as I mentioned before, it has 8 channels where you can acquire EEG. It has a resolution of 24 bits. So this is required because we have very small amplitudes in the EEG in the range of microvolts. And you need a very high resolution to be able to resolve these small amplitudes. For EEG, we usually measure frequencies from 0.5 to maximum 50 Hertz for surface EEG. And that's why you need a higher sampling rate and able to be able to acquire these frequencies. So that's why we chose 250 Hertz. And we have a very high oversampling rate to, again, reduce the signal to noise ratio and be able to acquire data in the microvolt range. Something that's special about the Unicorn is that we have hybrid electrodes. So you can decide according to your application or environment if you want to use dry electrodes or wet electrodes or gel electrodes. So The electrode is a hybrid electrode made from a plastic compound, which is conductive. And you can use it as dry electrode. And if you see that you have too much noise in your environment because people are walking around or you're moving a lot, then you can simply add gel and you get a good EEG. The electrodes are fixed to certain positions on the cortex that we know are important for different BCI paradigms. So in general, there are a couple of BCI paradigms around that we often use with surface EEG. So we usually use P300, SSVPs, or other visual stimuli, and that's why we place some electrodes on the visual cortex, that's on the back of the head, because it's very likely that we find the EEG signal there. Then we have a couple of electrodes on the motor cortex, that's basically in between your ears. And that's where we find certain EEG signals associated with the motor imagery. So if you're thinking about hand motions, you will find the activation on your motor cortex in between your ears. And we have some electrodes in the front. So in order, if you want to track emotions or use your EOG, electrooculogram, then you want to use the frontal electrodes. And if you use the EEG cap, you can simply put new holes into the cap and create your own montage that fits your needs perfectly. And besides the customizable hardware where you can place your electrodes wherever you want or need it, we also have a lot of different software tools. I'm also going to review these a little bit in a couple of minutes. And here you can see the amplifier in a little more detail with the hybrid electrodes. So you can see the hybrid electrodes have a certain shape, so they can pass through the hair and touch your skin perfectly, because that is very important, that the electrodes really touch the skin, because that's where the electrical potential from the brain is acquired from. So if your electrode doesn't go through the hair and doesn't touch the skin, you will not be able to measure EEG. And if you have too much hair or moving a lot, or dry electrodes just do not fit your application, then you can see there's a hole in the electrode tip, and you can simply put a syringe through it and add gel to your electrode. Here you can see the system in a little more detail. You can see that there's an electrode tip, and you simply slide it on the electrode. So you can put gel into. And if you want to clean your system, you can just slide the electrode off again and put it into water, because it's waterproof and there are no electronics involved, so you can clean the whole system perfectly. And here are a couple of different applications where we've used the Unicom before. So on the top left side, you can see a project that I've created for the Robo Exotica. This is a cocktail robotic and we created a gin tonic robot that was measuring your alpha beta ratio. So if you were more relaxed, you got a light gin tonic, and if you were stressed or focused, you got a strong gin tonic to relax better. On the bottom right, you can see some examples from Alex Guevara, who is a digital artist, and we did some projects with him where he wanted to integrate brain waves into his visual animations. And here you can see an example where he used the P300 component to modify his digital animations. Christoph already mentioned before the KUKA robot that we controlled with a P300 during the Ars Electronica Festival. And there have been plenty of robots that have been controlled with the Unicorn and with BCIs. And on the bottom right, you can see the Agent Unicorn project from Anouk Wipprecht. This was the start of the Unicorn project. So Anouk wanted to create a headset for children where the children with ADHD were wearing this headpiece, and whenever something triggered their focus, she wanted to turn on the camera to see what the children were actually triggered by. And this was the start for the Unicorn project, because we've seen that there's a need for cheaper BCIs that can be used in artistic or in digital art applications. And yeah, after creating the Unicorn, we also started the hackathon series, the Brain.io series that we are currently running. And we had about 30 hackathons so far or more, where we use the Unicorn in a lot of different applications. And it's always nice to see how people integrate the Unicorn into their project and to see new ideas evolving. And now we'll come a little more to the technical details that I will also show you in a little more detail afterwards, but just to give you an overview which software tools are available right now. We have the Unicorn Recorder, which is included if you purchase a Unicorn system. With the Unicorn Recorder, you can basically record and store data files in a CSV file format. So this is a very standard file format that you can implement in almost every programming language. Then we have a .NET API. So if you're creating C# applications, you can use the .NET API to include the Unicorn into your application. Then we have the C API. So if you're programming with C or C++, you can also use this software interface. We have the Unicorn BandPower application. This is a software that is calculating bandpower features in real time, and you can stream it by UDP into your application, or you could also store data in a CSV file. So this might be interesting for sleep projects, for instance, because the frequency bands change if you fall asleep, and you can see that in the bandpower features. Then we have a Unicorn UDP interface. So if you want to stream data into your own application via a network layer, this is a predefined interface that you could use. Or the Unicorn LSL, so lab streaming layer, or LSL, is a commonly used network interface. So you can stream data from one computer to another or from one application to another. The Unicorn Speller is a fixed application used for spelling using the P300 component. So if you're focusing on letters in this application, you can select them with your brain, and you can use this principle to spell, write words, or control robots, create paintings, or a lot of different applications have been placed on this software module. And we will also have a small live demo afterwards. Then we have the Unicorn Blondie Check. This is a neuromarketing tool. So you will see flashing images in this application, and images that trigger your attention will be ranked by the application. So images that trigger your application will be trigger your attention will be ranked to top, while images that are not triggering your attention will be placed lower. And that's how you can get an insight into your preferences, into your brain preferences, or at least see what is triggering attention for you and what is not. So there has been a very funny application from the BCI guys where they used it in combination with Tinder. So they placed a lot of images in this application, and your brain decided who you want to date. Then we have the Unicorn Simulink interface. The Simulink is a drag and drop real-time platform where you can easily create signal processing pipelines with a simple drag and drop editor. Then we have the Unicorn Python API. So if you're a Python programmer, you can also use the Unicorn. And pretty new is the Unicorn Unity interface. We had a very detailed talk on Monday, so if you want to have a lot of insights on detail, you can watch the talk on YouTube. The Unicorn Unity interface, there are actually two interfaces available. One integrates an ERP paradigm and the other one is CWeb paradigm. So these are visual paradigms that you can easily integrate into the Unity engine, and that's a game engine, so you can easily create games with this interface. And we also have open sourced a lot of these tools, or added a lot of tools as open source project on our GitHub. On our GitHub, we have the UDP interface. So we've created a very basic interface, and you can check the GitHub and extend it to your needs if you want to. The same goes for the lab streaming layer interface. There's also a very basic version available, and you could pull that from the GitHub and extend it to your needs. And we have a Unity raw data interface on the GitHub. So if you don't want to use a predefined paradigm with our Unity interface, you can also get raw data into Unity. But just as a hint before the hackathon, it's very hard to process EEG within 24 hours. So that's a very small amount of time. So I'd really recommend to go for the existing paradigms or interfaces, because it also takes us years to develop these tools, and within 24 hours, the time is very limited, and it's very likely that you will be lost in the signal processing. Then we have a Linux C API, so you can also acquire data on Linux or the Raspberry Pi. These are pretty similar. Then we have the Unicorn recorded datasets. We have a couple of datasets online that you can also use. These datasets include baseline EEG activity or alpha burst or alpha activity in this dataset. So you could also use datasets to create your signal processing pipelines beforehand, or use simulated data where you use extracted features without the requirement of a real-time application. On the GitHub, we also have a Unicorn Speller to Unity interface. So that has been used in a lot of hackathons beforehand, because before we created the Unity tools, we usually used the Unicorn Speller to send commands to Unity in order to create games. And now we have everything embedded into Unity to boost the user experience and make the step in a little easier. Then if you don't want to use any of our APIs and you want to create your own API, you can always use the Bluetooth API. So the Bluetooth protocol of the amplifier is open source. So there's the possibility to create your own APIs. The biggest advantage of using the APIs that we provide is that we already took care about converting binary streams into physical values and interpolating data that has been lost. And there have been a lot of tests. So the system might be a little more stable if you rely on the stuff that we already have tested, but you can always create your own APIs if you wish. Then we have an Android API if you want to go for mobile applications. And for 32-bit Windows PCs, which are rarely available, but still are, we also have a C API. And if you want to go for the creation of your own headsets, we have the mechanical drawings of the PCB of the Unicorn Naked available. So you can use this drawings as a reference if you want to create your own 3D printed case. And we have one example 3D printed case. And I'd shortly like to show you how this GitHub looks like. So the projects that I've mentioned right now are available if you look at the Unicorn Hybrid Black So they are structured for the different programming languages. So everything that is based on C# will be, you can find it in the Unicorn.net API. So we have the lab streaming layer, UDP interface, or Unity raw data interface in here. And same goes for all of the other applications. And outside, you will find the Unicorn Android API, the Unicorn naked drawings. And because Christoph mentioned before that there will be a presentation in the end of the hackathon, and you want to use the, or are supposed to use the PowerPoint template, you will find that in the GitHub if you open the Brain.io hackathons folder and scroll to the very bottom. There you have the PowerPoint presentation template. I can also post the link later on in the Slack, so you should be able to find that one. You can also find a couple of old projects from previous hackathons, but we can discuss that later on for your individual project in detail. Okay, as mentioned before, we've used the Unicorn Hybrid Black for digital artists with developers and makers. And the newest addition to the Unicorn are the game interfaces. So we also want to support gamers in creating their games. And the Unicorn is also used in a lot of research laboratories and by students. And therefore, we have a special education kit so you can step into BCI research pretty quickly. And this one consists of 8 Unicorn devices and all the software modules for 13,000 euros. And that's pretty cheap if you compare to previous amplifiers. So when I started, the USB amp was about 15,000 euros and was one device. Now you can acquire similar EEG quality for 1,000 euro per device. So that's pretty cheap. And if you want to purchase a Unicorn, you can do that in the web shop. You will also get the license keys there if you want to use some license application. Otherwise, you will find all of the open source tools on the GitHub, and a lot of the modules that I've mentioned beforehand are available for free. Yeah, and you can check previous applications on our YouTube. And that's also something that I'd like to show you. So if you want to do some brainstorming or find ideas, you can always check the Brain.io YouTube channel. And you will find a lot of projects from the previous hackathons that have been executed successfully. So you can get an idea what is possible within 24 hours and in which direction you might want to lead. And we will always be available during the hackathon to give you an idea, some ideas or some directions how to do your projects. Okay, this was the theoretical part of my presentation, and now I'm going to continue with some more practical part. I will show you the Unicorn suite a little bit. I will show you how to prepare the device and the subject or yourself. So usually I'm using the Unicorn myself, and it's also possible to gel and use it without the help of someone else. So this is the Unicorn Suite Hybrid Black, where all of the tested and released modules are collected. And you can see you have an application section. So these are the predefined applications that are compiled, and you can run and use them. And then we have some development tools section. So you want to use this section if you want to create your own programs from scratch. So just as a small hint, all the APIs forward EEG data is raw data. So there's no signal processing applied. So for the hackathon, I'd rather go for the applications that are already predefined, which have signal processing and classification and all these issues solved, because it's very hard to extract features from raw data in real time in a short amount of time. Then there's the licenses tab, where you can unlock features. So some of the software modules are licensed, and if you want to use one of these licensed modules, we can hand out some license keys during the hackathon, but we have to collect them back afterwards. So please do not forget to deactivate them. We will prompt you before the hackathon ends. Then we have the My Unicorn tab. So in here, you can check the hard and software environment of the Unicorn, and you can check if everything is set up correctly. So the Unicorn is delivered with an Bluetooth dongle, for instance. You can check if this one is configured correctly. Then you have the discovery and paired devices dialog. So in here, you can pair with devices and check if you can connect. So I'm holding a Unicorn in my hand right now, and I already paired it. And now I'll make a connection test to see if I can continue. Yeah, so connection test succeeded, and everything should be set up correctly. So the first application I'd like to show you is the Unicorn Recorder, because right now I'm going to set up the device on my colleague Bernard, and we want to see if we can get some good EEG signals. So therefore, I'm going to Therefore, I'm going to apply the cap on Bernard's head, or he can do his own. Okay. So before starting with the application, I have to open the Unicorn Recorder. And if you want to look at good EEG data, you usually want to get it into a amplitude range of minus 100 microvolts. And as you can see right now, we didn't apply any electrodes yet, and the signal is floating around in the nowhere. To get some good EEG signals, we have to apply some pre-processing filters. So we have a bandpass filter of 1 to 30 hertz or 0.5 to 30 hertz. That should be fine for most of the applications you want to do. So if you want to use P300, you should go for 0.1 to 0.5 to 30 hertz. But if you just want to measure alpha waves, for instance, you can go up to 2 or also 5 hertz. And if you're located in the US, you have to apply a 60 hertz notch filter, because the power line hum is located at 60 hertz. But in Europe and a lot of other countries, the frequency is at 50 hertz. So now this EEG still looks pretty bad, because we didn't apply the ground and reference electrodes. And the ground and reference electrodes are required because you're measuring your EEG signals in a bipolar manner. And this is so it's important that you have a good connection to these two electrodes. And therefore, we use the sticky electrodes, and we usually place them on the bony structure behind the ear. It's the mastoideus. So I'm going to do that now for Bernard. So here behind the ear, there's a bony structure, and we place the electrode here, and that's the perfect location for the sticky electrode. And on the other side, we do the same. So just check if you're doing that you have not too much hair underlying the underlying, because the better the connection, the better your EEG signals will look like, since all of the electrodes are measured in reference to these two electrodes. Okay. If we now sit still.
Sorry?
Yeah. So don't move. Don't move. And if you now sit still, you can see already that some electrodes are floating in. So actually the signal already looks pretty good. So Bernard, can you blink a couple of times? So now we see eye artifacts on the first channel, and we can be sure that we have some good EEG signals. Now you can clench your teeth a couple of times, and we can see that we have muscle artifacts from the chin in the EEG. So you want to avoid that if you are running an BCI paradigm. And now you can close your eyes for about 10 seconds. And now you can see low frequency and high amplitude artifact or signals. So this is the alpha wave, and that's a real EEG signal. So if you do this free test before starting a BCI paradigm, you can be sure that the EEG is pretty good. And right now we are a couple of people in this room and we are moving around. So you can see with dry electrodes, I can easily disturb the EEG. And you want to avoid that because you want to have some good EEG. So if you're alone in your room and you're sitting steadily, it's perfectly fine to go for the dry electrodes. But if you have a room with a lot of people or you're in a lab and people are moving around, disturbing your EEG all the time, you want to avoid that because then random things might happen. And in this case, you would add some gel. So right now, I'm going to add some gel to all of the electrodes. Should work out pretty quickly. All right. Put on the Augustus again. Okay, now we can see that the EEG signal settles again. And now I can move around and check if I still have some bad electrodes. So maybe electrode 6, I have to prepare it a little better. Maybe electrode 1 looks a little bit distorted. So in order to get a good signal quality, I usually add some gel and rub the electrodes a little bit through the hair. Then I wait until the signals settle again and do the EEG test again. So Bernard, can you blink your eyes a couple of times? So blink, yeah. You can see EOG artifact, especially on the first channel. Then clench your teeth a couple of times. That's also fine. And close your eyes for a couple of seconds. And we can see some big alpha waves again, but we still have one floating channel. So channel 6 still looks a little distorted. So we'll simply prepare it a little better. Okay, so the EEG signal looks fine. And if you can get it into a amplitude range of plus minus 100 microvolts, then it should be fine for a BCI application. Okay, the next application I'd like to show you is the Unicorn Speller. And this is an application that implements a P300 paradigm. And we used it pretty often to control games or similar, or robots. And we created paintings with the Unicorn Speller. So there are plenty of applications available. And for a BCI system, you usually have a calibration phase, and then you can apply the system. So before starting, we check the signal quality again. We have some frequency swings. Maybe we can. So if some artifacts are visible on all of the channels, it's very likely that the result from the ground and reference electrodes. And we want to avoid that. So I'm placing the electrodes a little bit different. So it's very likely that some cable is moving or is pinched if you find these artifacts. All right. Or if the electrodes don't have a good contact to your subject. Maybe can you quickly take off the glasses? We want to wait until the signal settles a little bit. Maybe my electrodes are also a little dried out. And then I usually add some gel underneath the ground and reference electrode to ensure that they have some good contact. Looks better. So now we have some good signals. My electrodes were a little dried out. And we can start with the calibration phase. So for the calibration of the speller, we usually take 3 to 5 icons that will flash. So in this case, I will take TDB. And the task for Bernard right now is to focus on each of these letters, and they are going to flash. And he has to react mentally to the flash. And that triggers a P300 wave. And we can then use this P300 component to check if he's focusing on an icon or not. And therefore, we have 3 icons that he should focus on, and he should ignore all of the other flashes. Okay, so I will set 30 flashes per icon. And that means we will have 90 flashes in total, and then a classifier is calculated. And then we can check if the system has been calibrated properly. So right now, Bernard is focusing on the T. And whenever the T is flashing, he's counting the flash mentally. So now he's focusing on the D, and whenever the D is flashing, he's counting the number of appearances, like 1, 2, 3, 4, and so on. And that's the signal the classifier is trained to. So after the training phase, we can check if the system learned if Bernard is focusing on something or not. And then we can use this classifier without any targets or instructions. And Bernard can select items by will. And the last item is focusing on the bee. And he's only counting if the bee flashes and ignoring all of the other flashes. After the training phase, we have to check if the calibration was performed successfully. So if the calibration was not successful, you have a couple of options to improve your BCI performance again. If you had a lot of artifacts during the training, you should recalibrate the system and try to minimize the artifacts. So if your EEG was not good, you should check that you have a good EEG signal quality. If you have been moving and so on, you should try to sit steadily. You can increase the number of flashes before selection or decrease them. And that's what I'm going to show you right now. Now we want to test if the classifier was successful. So Bernard will spell BCI. And we can speed up the system already a little bit. So for the first, for the calibration, we had 30 flashes, and then we move to the next item. So we'll now increase the speed a little bit. And after 10 flashes, a selection is done. So I start the paradigm again. And now we can follow if the BCI is able to classify correctly. So misclassification for the first, check for the second. Second was correct. Okay, 2 of 3 have been wrong. So in this case, during the calibration phase, we've seen that the EEG turns bad often. So it's very likely that we do not have good EEG signal. Now it looks good again, but it's swinging a little bit. And you have a couple of options to improve your performance. So he was able to select something correctly, so we can increase the number of flashes. So with more flashes, the signal should the system should behave has more time to classify correctly, and with less flashes, the statistical security is not that as high as with a lot of flashes. And the second possibility is that you recalculate the classifier with more training data, since we had a lot of artifacts in the training and the signal quality indicated that we have had EEG pretty often. We could do something around 100 to 150 flashes. Then we usually know, even with some artifacts, the system works properly. And if you have a good classifier and some good EEG, you can go as low as 2 to 4 flashes for selection. And if you want to integrate this application into your BCI system or into your game, you can use the network output. And this network output basically sends an item from one application to another using UDP. So in the Unicorn suite, you also have an example code in the manual. So you can open the manual over here. So there's the Unity speller interface on the GitHub if you want to integrate it into Unity. And if you want to integrate it into a C# application, you will find a programming example in the manual on the very bottom of the speller section, how you can integrate the BCI into a C# application. So we're almost there. The section is called Programming Application Using Unicorn Speller's Network Output, section 21. And here you can see how you can use the Intendix or Unicorn Speller to create your own application using C#. If you want to do it in Unity, I refer to the GitHub page and you can use that one. And this is an example how you could use this application to spell letters or words, but you could also change this for a robot control. So I show you the Sphero board, for instance. Here we have arrows and directions, so you could use this application to control a robot and send the commands that have been selected from the network interface to your application. So we'll show you the command like. So to test your network output, we have this test network output program. And now I'm using the loopback adapter on port 1000. And now I'd like to show you how the speller would send the output from one application to the other. So if I send forward, it should be received in the other application. And now we have sent one command from the speller to the other. And we can also do that in real time. So Bernard is focusing on some item. And then the item will be sent from one application to the other. And we can follow that process. So again, after 10 selections, the selection is done. And he selected the spin item. So, so that's how you can use the speller to control an external application. But there are plenty of possibilities. You could control a painting application, a robot, a game, whatever you want. You just have to integrate the P300 paradigm. Then I'm going to the next application that will be interesting for the sleep projects, the band power application. So band power features, so the EEG has a couple of different frequency bands that are interesting for applications. So you have delta, theta, alpha, beta, and gamma waves that you can acquire with surface EEG. And using this application, you can integrate these signals in real time. So here you can see on the right-hand side the signal quality scope, indicating that we have a good signal quality. So I asked Bernard to close his eyes for 10 seconds. And this is an alpha wave, and you can see that the channels representing the alpha increase in the band power. So on the bottom, you can see the band power calculations in real time. If he has his eyes opened, other frequency bands besides the alpha are most present, and if he closes the eyes, the alpha raises. So now he closed his eyes again, alpha waves appear, and the alpha band rises, becoming to the most present frequency band. And if he opens his eyes again, you can see the other frequency bands raise. So usually delta waves only appear during deep sleep. Theta waves appear if you're very relaxed or in a drowsy state or in a very, very relaxed state. Alpha waves appear if you're conscious, awake, but relaxed. So if you close your eyes, for instance, your visual cortex turns off and alpha waves appear all over the visual cortex. So we can try that once again. Bernard, please close your eyes. And now you can see big alpha waves appearing, the alpha wave coming most present, and that's because he closes his eyes and the alpha waves become the most present frequency band. So if you're doing some cognitive work, beta waves are going to be most present. That's something you will measure during high workload, for instance. And gamma waves is already pretty hard with surface EEG because these are very high frequency bands, and with surface EEG you have a lot of dampening factors like the skull and the tissue in between and so on. So you need a very, very clean and noisy environment as well as gel electrodes to measure them.